Hello, everyone. This is Alan from PureState, the team developing Moonbeam. And yeah, I want to welcome everyone to the Moon Builders track, in which we'll kick off the sessions with a fireside chat with Rob Habermeier, Polkadot Co-Founder. And here he is. Hi, Rob. It's a
Hey,
pleasure to
Alan.
have you with me. How are you doing today?
I'm doing well, thank you. Just getting over a cold, but all things considered, doing fine. How are you doing?
Oh, okay. Yeah, good too. I hope I won't get one soon, but yeah.
Yeah, could
All
somebody
right.
just move the cameras like a little bit?
Yeah,
Get some
just a little bit.
distance.
All right. Well, yeah, thank you for being with me. We have a little chat, and yeah, I wanna go with some technical discussion with you. But before that, I also want to summarize a little bit what has happened this year, because I think both on Moonlit side, where we had our launch, and we had a lot of continuous development for shaping, all the features around it, and I think we also spent a lot of time experimenting with XCM, also a big thing. Um, I want to get like your impression of how was 2022 from your side.
I mean, pretty good, all things considered. Well, let's see. We had the first pair of chains going live in around January. Of course, we'd had them on Kusama since June or so of 2021. Um, and what we've seen is like, I think it's almost 70 parachains in the ecosystem. Of course, the bulk of those are on Kusama. Now, I think that it's not simply about the number of parachains, but of course, like the channels, the messages, the sort of interoperability. Um, what we have seen is like there's a lot of people building on Polkadot, and definitely a lot of people building on sort of those next layers outside of Polkadot, so deploying on Moonbeam or other networks, which is also a totally valid way to build on Polkadot. What I think I really would like to see more of going forward is experimentation with like what makes the Polkadot architecture truly unique. So really leaning into those ideas of specialization, or like what can you do with a blockchain that you can't do with a smart contract, and really like seeing builders make those choices effectively. I think that there's so many projects that actually are just better off as a smart contract. But then there are also these really like cool things that you can do with your own blockchain if you decide to build that.
Yeah, I totally agree. I think building the parachain offers a lot of flexibility and a lot of power compared to a simple smart contract. And I don't know if you heard actually, Derek mentioned this morning, this idea of kind of containers for applications that are, a mix in between what a smart contract is, by being, something simple because you don't have to deal with all the infrastructure of creating a full parachain as it is, and also the possibility of having the directly the security of a parachain or the relay chain actually behind it.
Yeah, I mean that's definitely an interesting direction to head, and it kind of ties into that whole block space conversation that we've been having. I wrote a big blog post a few weeks ago about that. You can check that out if you want, like, to read some background on that. But ultimately, when you have you have the service that's being provided, which is like block space, right? It's like a verifiable execution of some kind, and it matters. When you're a product that's pre-product market fit, and you don't have that budget for you know infinite amounts of block space, because there aren't that many users using your platform, right? You basically have to sacrifice either quality or quantity. So you buy a worse block space product, or you buy less of it. I think the approach to like containerization and moving towards this almost like cloud vision of state machines that are secured by Polkadot is saying, hey, well, the thing that we really care about is super additive value, and we don't want to take on super additive risk with that. So having everything under the same security umbrella, just getting as many state machines on there as possible, and then sort of scheduling them in a cloud or containerized style way is an idea that really appeals to like the architecture of Polkadot.
Yes, I think, yeah, you're totally right. I mean, as a developer, when when you have an idea over the weekend and you're like, yeah, I'm gonna create that great project, but I need to draft it and everything. Now I think most people, especially the young developers, they just think about, okay, I'm gonna deploy I'm going to write quickly my project, like whatever TypeScript or any other language. And I know there will be a cloud service that'll be able to do all the stuff behind that I don't need to care about, hosting it, about making sure like the security is well defined behind it and all the things. And in over a weekend, you have like a full service already deployed. And I think that's a good direction to aim for like Web3 kind of applications. And yeah, can you tell us actually a bit more, explain a bit more, maybe briefly, but about the block space? And I think what we also talk about is the para threads that Polkadot is gonna implement soon.
Yeah, sure. So block space is this term that's been gathering some usage over the past maybe year. It's been around for a long time, but I think people are really starting to figure out like how to pin it down. But what it basically refers to is the work that is done by a blockchain. Like, what is a blockchain actually offering? Well, it's offering some amount of block space, and that block space is kind of generalized. It's not actual like storage space measured in bits and bytes, although that is a factor. It's kind of a mix of factors. So it's like the amount of data or the amount of time that it takes to execute the transactions. And these are all the things that like validators or miners need to do under the hood, right? We're kind of zooming out and saying, well, okay, this is the generalized thing that a blockchain offers, and how do we compare the offerings of block space between different systems, right? Like, what's the difference between Bitcoin block space or Ethereum block space or Polkadot block space or Solana block space? And I kind of take it down to three qualities, which is the quality or security of the block space, like how good is the consensus actually? Everything has a cost, and how secure is this? The availability of it, like how much is being produced, right? How much can you buy? Is there a large amount of this block space being produced, or is it a very small quantity that has to be competed over, right? And this is where we get into stuff like scaling solutions. And then the flexibility. And I think this flexibility component is really important. Where it refers to like, what can you do once you buy this sort of generalized block space, like a raw material, right? Like, what kind of things can you convert this raw material into? And something like Ethereum block space, when you're working on the EVM, it's like it's fairly flexible. Like, in principle, it's Turing complete, but you are limited to like what the EVM is particularly good at. You also spend a lot of time doing stuff like gas metering. You're also limited in like scheduling stuff or doing stuff that's not triggered by user transactions. So this notion of flexibility is kind of about like how general is this raw material that the blockchain is providing. So with Polkadot, like, we just have this. We use WebAssembly for that. So it's like any WebAssembly program that you can upload, right? It's like that's what you can use your block space for. It can handle internally stuff like user transactions. It can also do scheduled stuff. So you kind of have it's kind of like a block space transformer, right? You kind of take this very raw block space that's general provided by Polkadot, and then you specialize it to something that's a particular protocol or application, app chain, or something like that.
Yeah, that's great. And I think the choice of using WebAssembly is definitely the right one, with all the languages supporting it and being like kind of well optimized also right now. Yeah, and I wanted to hear more about the para thread, and maybe a little bit more technical, going into the asynchronous backing, which is a feature that I'm really excited about, and I hope to get some good news about it, of when we're going to be able to experiment with it.
Yeah, absolutely. So let's start with para threads. And this is both like, I think anchoring this in the discussion of block space is really crucial, I think, to understand why we've chosen these features, and maybe even to do them in the order that we have. The idea of para threads is like, well, okay, the current way to run a blockchain on Polkadot is you write something with Substrate, and then you can upload it, like the code of it, that WebAssembly code, to the relay chain, and then you can participate in auctions, right? You can do that directly, or you can use crowd loans, or you can even like maybe use some alternative service that's a bidder in auctions. But what you're ultimately buying is block space, like reserved block space for 2 years, right? Or 6 months, 12 months, 18 months, or 2 years, right? And this is a really like large amount of block space to buy. I like to use the cloud computing analogy, where I say this is like a reserved instance in cloud computing. It's like you're buying in bulk, because you're saying we're going to have the demand for all of this block space. Whereas parathreads are a bit more like spot instances. They're just-in-time block space. It's saying, well, you do the same thing. You write all your code in Substrate. You build a runtime. You upload that to the chain. But instead of participating in an auction for like a very long reserve period of block space, you just do it just in time, like whenever you need to make a block. So you can imagine like Oracle services that maybe don't need to like push data every 6 seconds, but rather once a day or once an hour. You can imagine other things that don't need to make blocks every 6 seconds or 12 seconds, and they just buy space when they need it, or chains that basically don't run unless there are user transactions to process. And the key is that it's I think this is really important for builders, basically, especially in these market conditions, to look at these types of offerings where like you don't want to be leaking your token to validators for buying block space that you're not going to use. So this is kind of the main motivation behind parathreads, and this is kind of attacking like the block space allocation problem. And then we also have asynchronous backing. So the idea of asynchronous backing is it's attacking the block space availability problem, right? Like how much block space is there? So it's kind of an umbrella term that we've used for a bunch of different code changes that kind of go together. But the goal is essentially it's a reuse or a type of buffering. It kind of decouples the logic of growing a parachain from the growing of the relay chain itself. So it can kind of grow in parallel a little bit, and then whenever there's a block ready on the parachain, it can get put into the relay chain. That's not really how things work right now. I mean, in fact, asynchronous backing has been how we always wanted it to work. Of course, the engineering just takes time. So like the existing version of parachains should be viewed as almost like an MVP, where asynchronous backing takes that to like the full enabled version. But the main effects that you'll see from asynchronous backing are 6-second block times on parachains. So instead of 12 seconds, it'll be 6 seconds, as well as just more time for validators and collators to put blocks or put transactions or work into those parachain blocks. So we're still waiting on numbers on those, but we're targeting like 1,000 or 2,000 transactions per second per parachain.
Wow, that's a lot, yeah.
Where, I mean, this is based on like what we've seen just, with the same numbers on Substrate itself. Like we have to wait for concrete numbers coming out of that. But the goal is to take the aggregate transaction throughput of the network much, much higher. So where we are on that, I mean, we have like a massive feature pull request open. It's like 15,000 lines of code, and like there's 7,000 more coming in on pull requests that we made into that. So it's been quite a lot of engineering effort. I think we're gonna see a preliminary version of that around the end of the year. So that will be simply the 6-second blocks, and then that's going to be the base for all of the experimentation that needs to be done sort of on the collator side, right? Like essentially it's this question of collator selection, as we call it. So like, as you know, rollups have this issue with sequencer decentralization, and like who are the sequencers and what rules do they follow? And parachains are basically kind of rollups, right? And collators are kind of an analog to sequencers. And the parachains themselves will have a lot of freedom in like, the rules that collators need to follow. But then it's a matter of coming up with algorithms that really leverage this asynchronous backing protocol to the fullest, right? To balance things like transaction latency and transaction throughput. So that is something that's going to be iterating, I think, over the next several years, right? To really refine that, because it's it's a new area of research. But yeah, so on the core side, we're going to see the tools for asynchronous backing, I think, launch before the full effects of that are going to be realized.
Yeah, that's a pretty interesting and exciting idea, definitely, to be able to separate kind of the relay execution, parachain execution. And I think when you talked about parathread, something also I usually I say to help people to understand is it's a way of seeing also your CPU, because I think a lot of people, developers, also gamers and everything, and they know how important it is to be able to use the different cores, because in your CPU, you usually have plenty of cores. That's how you get a lot of power. And I think the idea behind parathread is to basically better support the multiple cores kind of, that the Polkadot is offering, so that when a core is not doing anything, it can be used by another project actually to rent that kind of core and being able to use the block space that it's providing. I think it's a very important step to allow, you said the 2,000 transaction per second. That will be very amazing. I think with Moonbeam, we had a bit of struggle at the beginning with those, but we have improved a lot over time. And I think right now we're really waiting for this feature to start testing it and moving forward. We still have a few more minutes. I wanted to discuss a little bit about being a developer for Parachain or for future Parathreads. And I know when I started, like, being a developer for Parachain was kind of a new thing, and it has been quite challenging at the beginning. It took us, Moonbeam has been like in development for 2 years now. And and I think things have changed a lot. Like the code is more friendly, the documentation has improved. There are a lot of tools around it, a lot of now, like especially around security and testing. I work a lot on that area. I like it. What do you think can also be done to help the developers, and how do you see them, moving into the Polkadot system? Do you think they will just start with small smart contract to get the ID done, and then there will be a path to go into Parathread or more? Or do you think it's like there will be a new kind of framework just dedicated for those small projects trying to go into the Polkadot ecosystem?
Yeah, that's a really good question. I think a lot of it is going to be about building proper funnels for developers, right? Like when somebody comes to the landing page of Polkadot and says, well, how do I build on this? That it directs them to all the different ways that they can build in the network, right? And instead of, I think that we really need to move away from this narrative, like the way to build on Polkadot is to build a parachain, but rather to funnel developers to like building smart contracts or maybe building blockchains, but also building things like bots, right? Like networks, MEV, front running, maybe some of those things, right? Like a lot of these protocols require some kind of agent who is incentivized, but ultimately some developer actually has to build that. There are opportunities there, right? The sort of symbiosis between on-chain and off-chain. So building good funnels to bring developers to the different places that they can interact with the network. I think there will definitely be paths. We're actually exploring this a bit with Ink, but I think you could do similar things with EVM. Like, as we said, the logic of a parachain is really just, it's a piece of WebAssembly code, right? So it doesn't really matter how you get that WebAssembly code. Like that actually could just be like a single smart contract, right? Like you could build wrappers that say like, hey, turn your smart contract into its own blockchain just for that smart contract. And those could kind of be like ramps for somebody to initially deploy just as a basic smart contract, and then just have tooling to transform that smart contract, whether it's an EVM contract compiled into WebAssembly or whether it's built.
I was thinking about it, yeah. The EVM to WebAssembly, maybe it's something we should work on, and like that, all the projects on Moonbeam that ask us, how they can grow and scale even more, we could tell them, hey, well, now you have the possibility to move to WASM and have your own kind of Parathread or,
Yeah. Exactly. So I think that's definitely something interesting to play around with. Like the architecture of Cumulus, which is sort of like our build a parachain, it's a piece of tooling between Substrate and Polkadot, basically. It's like that's actually a fairly general piece of code, and it wouldn't be too hard to just like split it off of the dependency of Substrate and just say like, hey, here are like a bunch of libraries for basically building a collator out of a piece of like core logic. And that could be built around a single smart contract or a bundle of smart contracts. I think that those types of on-ramps for people to just say like, I'll start with a smart contract and see if I need to create my own chain.
That would be awesome. Definitely. I mean, starting with something small and being able to launch it like that would be definitely amazing. I think we're running a little bit out of time. Yes. All right. Well, thank you very much, Rob. I think there's still a lot to learn about that block space, the Parathreads, and the asynchronous backing and all the technical details about it. But that will be for another time. I think following us will be Kevin. All right, here is Kevin. So thank you very much, Rob, and talk to you later.
Thanks, Alan. Thanks for having me. Bye-bye.
Thank you so much, Alan and Robert.